What's up? I'm Vin, and today I want to take a look at geometric sequences. So a geometric sequence is when you start with a term and you multiply by the same thing each time to get from one term to the next. And we call that thing the common ratio. So this is the general formula for the nth term of a geometric sequence. So now let's look at a few questions. So for the first few questions, let's just find r, where r is the common ratio of the sequence. So if we look here, we'll start with one that's easy. If this is our sequence, the trick to finding r is you have to notice the pattern as what are you multiplying by each time to get from one term to the next. So when you think about this, you could just see to go from one term to the next that we're just multiplying by 2. So we're doing times 2 each time. So that tells us the common ratio is r equals 2. Now if we look at another example here, let's say we call this question 1. In question 2, let's say now this is the sequence. So we have square root 2, 2, 2 square root 2, and then the next one will be 4, and then let's say 4 square root 2. Now, one nice thing about geometric sequences is if you ever do get stuck, if you can't do this in your head, let's say you don't recognize that r equals square root 2 is the common ratio. So let's say it's not obvious that this is the answer. Well, what you could do is you could take any two consecutive terms and divide one term by the one before it. So you see here we could do 2 square root 2 divided by 2, and the 2 over 2 cancels, giving us just square root 2. This would work if we did these two terms. So let's say I did 4 square root 2 divided by 4. This would also tell me square root 2. Now, a less obvious one would be if you divide the first two, r divided by, so r equals 2 divided by square root 2. It isn't obvious yet, but when you rationalize the denominator, this becomes 2 square root 2 over 2. Once again, giving you a common ratio of 2. So just divide any two consecutive terms if you want to find the common ratio. So we'll look at one more question here. So let's say this time around, for question 3, something a little bit less obvious. Let's say this is the sequence of terms here. We have 8, negative 6, positive 4.5, and then next we have negative 3.375, and this list continues. So one thing that may jump out at you is that the terms of the sequence alternate in sign. They go from positive to negative, back to positive, back to negative. So if it's not obvious what r is here, remember that little trick I just said a moment ago. You take the term like negative 6 and divide by the one right before it, which is positive 8, and this reduces to negative 3/4. So r for this one is negative 3/4. Now remember, we could have done this with any two consecutive terms. If we would have done 4.5 over negative 6, we would get the same thing. So let's look at the following question. So for this question here, we have a few things to do. First, we want to find the common ratio. So if we look at this one, to get from 5 to 15 to 35, we're just going times 3. So this represents we have r equals 3. Now the nth term, we're going to use this formula from before. It's equal to a times r to the n minus 1. And I didn't mention this on the main page here, but a represents the first term. So in this case, a would be equal to 5. So if we want to find the nth term, we just plug into the formula. We have 5 times r is equal to 3, and this is being raised to the n minus 1. So what's nice about having a formula is that once we find the formula, so we had to find the r value, the formula for the nth term, and now we want to use the formula to find the 8th term. Now, just know we could, if we want to find the 8th term, just keep going times 3 the whole way. But we could also just find the 8th term by plugging into the formula. So this would be 5 times 3 to the n is equal to 8 this time. So we have the n minus 1. And the n minus 1 is going to give us to the 8 minus 1. So this works out to 5 times 3 to the 7th power. And when we work this out, the 8th term of the sequence is equal to 10,935. So now let's look at a more challenging question. Okay, for this question here, we're going to be given the second term of the sequence, the fifth term of the sequence, and we want to know which term of the sequence, the geometric sequence, is 468,750. So this question is a bit tricky, but let's start with the main formula, that the nth term is equal to a, the first term, times r to the n minus 1. So if we set up these formulas, let's say here I say a sub 2 is going to be equal to a times r to the 2 minus 1, or just r to the first. But if I were to run n equals 5 through this formula, that's going to give me a times r to the 5 minus 1 is r to the 4. But now what could I do with this? A sub 5 is equal to 3750. So I could set up this equation here. A r to the 4th equals 3750. And then a times r is equal to 30. So what we could do is we could set these equations up next to each other and divide them. So I could say then that a r to the 4th divided by a r is equal to 3750 divided by 30. So once again, if this quantity on the left is equal to this quantity on the right, and the same thing with these two, then we could divide them. There was an old postulate that said that equal quantities divided by equal quantities are equal to each other. Okay, so when equal quantities are divided by equal quantities, the quotients are equal. So that's kind of the idea that we're using here. And now we just simplify it. A divided by a cancels. R to the 4 divided by r to the first is r to the third. We could get rid of trailing zeros here. And when you do 375 divided by 3, that's 125. And notice this number is a perfect cube. So that's going to make this question work out really nice. This tells us that r is equal to 5. So now with this, one thing we could do right away with that is to go from one term in the sequence to the next. That means we're multiplying by 5. So if I want to go backwards and say, what's the value of a? Well, the value of a would be taking the second term and dividing by 5. So the second term is 30. If we divide that by 5, that tells us the first term is 6. So now we have r, we have a. We could write a formula for the nth term. So this is going to be 6 times, and our r value is 5 to the n minus 1. Now from this step here, we want to know which term is 468,750. So at this step here, we could set 468,750 equal to 6 times 5 to the n minus 1. So now we just have to do the algebra. We could divide both sides by 6. Now there's a few ways that you could proceed from here. One thing would be to just keep breaking this down to a power of 5. You could just divide this by 5 indefinitely and do a common base solve. Otherwise, what we could do here is we could take the log of both sides. And if we take the log of both sides, that's going to give us log of 78,125 equals log of 5 to the n minus 1. And now properties of logs tells us we could bring n minus 1 out in front. So this will give us log of 78,125 equals parentheses n minus 1 times log 5. And now if you divide these, this is going to get us a step closer to solving for n. So we look here, you just have to punch this into a calculator, and this will tell you that n minus 1 is equal to, and if you type in log 78,125 over log 5, this is simply going to work out to 7. And then we're just going to add 1 to both sides, and that tells us that n equals 8. So when they ask us here, which term is 468,750, we would say the 8th term. And if we wanted to check our answer, what we could do is we could take something like the 5th term and multiply it by 5 to get to the 6th, multiply by 5 again to get to the 7, and multiply by 5 a third time to get to the 8th term and show that it matches this. Okay, well, this is going to conclude this video on geometric sequences. If this video was helpful, please like and subscribe. It really helps me grow the channel, and if you got any requests, just leave the topics you want me to cover in the comment section below. And thanks for watching.